Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. We are from B21 CAP0448. Right now we are going to present our Capstone project. Our team consists of 5 people. First, we have Rizky Fadila from Universitas Negeri Malang, currently enrolling in Bangkit as Mobile Development Path. Next up, we have Tajrin Nur and Ahmad Izzuddin Hilmi from University of Mula Warman, currently enrolling as student of Cloud Computing Path. Next up, we have Muhammad Haris Fadilah and Furqan Auliuddin from Institute of Technology 10 November, currently enrolled as machine learning student in Bangkit. Now, introduction of our app. Blind or visually impaired person usually going out with someone to assist them, but not often. Some cases they want to go alone, and this is possible by a guide dog, or if accessible, there are a really infrastructure built by their government to help them around. But whenever they get to new places alone, it's hard to identify where they were at the moment. That's why we wanted to come up with a new solution. We created a simple app that can help them in that situation. Deepsee is an app that helps visually impaired person to identify the room where they stand and identifying the objects on that room. With this app, they won't need to fill the wall to looking for braille signs. The background of our app. According to the Ministry of Health, there are 6 million people in Indonesia suffer with visual impairment. In contrast with this fact, there are still limited infrastructure for disability person built by our government. Sometimes visually impaired person wants to be independent, going around and doing stuff, and this is possible with their help of their smartphone. There are thousands of apps can be downloaded in App Store and Play Store, so it could support the visually impaired person to do their activity on daily basis, and that's why we want to join this movement as well. Now, why our target market needs our solution? Purposely driven, we want to help the visually impaired person to be able to quick scan the room they're at with the help of their smartphone. With data driven, up to this moment, there are any application that offer a feature that can identifying a room and object both at the same time. And any foundation or profit or non-profit organization that has been working with and around the visual impaired community hopefully can benefit from our app. Now, our project uses 3 Bangkit learning paths. They are machine learning, mobile development, and cloud computing. And here's how we combine the 3 paths into our project.
The source of the indoor scenes dataset comes from the MIT research. The dataset is published on the MIT and the dataset can also be found on Kaggle. From the description, the dataset contains 67 indoor categories and a total of approximately 15,000 images. The number of images varies across categories, but there are at least 100 images per category. All images are in GPG format. We picked 20 indoor scenes categories focusing on working space and public space. We built a baseline CNN model for the classification of indoor scenes. In general, there are 3 types of layers to build a CNN architecture model, namely convolutional layers to extract the various features from the input image, masking layers to decrease the size of the computed feature map to reduce the computational cost, and fully connected layers to connect the neurons between the 2 different layers before the output layers. And we get the results of training accuracy of 70% and validation accuracy of 43%. The results still give poor performance. Based on the graph, the loss function stack is above 2.0 and does not reach optimal confidence. To improvise the accuracy metrics in the model, we use one of the transfer learning models, namely the MobileNet model. MobileNet has several advantages, namely smaller model size with fewer number of parameters and smaller complexity with fewer multiplications and additions, based on the documentation of the TensorFlow Lite model. This is architecture for MobileNet model. After improvising the model, the training accuracy increased to 99% and the validation accuracy increased to 78%. Although slightly overfitting, the results of improvised models are better than before and can be used as models in applications. Then, the MobileNet model was converted into TensorFlow Lite model.
For the object detection, we use a dataset from OpenImage dataset physics. It contains a total of 16 million bounding box for 600 object class on 2 million images. The images are very diverse and often contain complex scenes with several objects. The dataset consists of separate train, validation, and test sets. We picked 6 object class, which is big enough to be used or to be recognized from some distance and commonly found in indoor scenes that we choose from the MIT indoor scene dataset. We use 1,000 boxes for each class for training and 200 each for validation. In the first iteration, we try to use YOLO v4 for the model. YOLO v4 is latest darknet-based implementation of YOLO, a state-of-the-art object detection system. YOLO v4 is one of the fastest and most accurate object detection model. After 306 casts from open image dataset, it reached quite a good result. The drawback of using YOLO is its huge size. It's around 244 megabytes and it's unsuited to be used in mobile application. Then in the next iteration we use SSD MobileNet v2. It's a modification from MobileNet v2 that use a single shot multi-book detector to be used on object detection. It's faster than RPN based approach because it can detect multiple objects with one shot only. It's lighter than YOLO, so it's more suited for mobile application.
Okay, next we are in Android development studio. In this app version, we decide to use product by smartphone and use Android Studio for the platform to create this native app and integrating machine learning model. And other than that, we use Java language programming. This app is also combined with cloud computing. We're using file-based Google Cloud storage. And for machine learning, we're using integrated TensorFlow Lite model for Android. Additionally, we integrated API for the coordination result. Next, in this main feature, there are four main features for this app, Deepsee apps. So the first one is we can upload your feedback using create the result with three options, and then the voice result classification that can make a sound when the camera is detecting your skin. And the third one is classify. In this main feature, when you open the camera, live camera, it can be detect in your skin and object detection. And the fourth one is the real-time detection, which is detect in your skin and detect object. Next.
For cloud computing, we decided to create a multi-diagonal bucket with service account, access to Android using Firebase. We also make a security and availability option, so we can monitoring a service and make an alerting that is set to request metric from a bucket, and also if bucket has a big ingress bandwidth. There are some screenshots for alerting notification, dashboard of monitoring, and also Google Cloud Storage object details. Next. For documentation, there are three sections, which is ML, Android, and also cloud computing. ML make download and review the dataset, make ML model, and also convert it to the F-Lite model. For the Android, it initialize a native Android and integrate the TensorFlow Lite model, and also integrate API for the recognition result of cloud computing. For cloud computing, create API for cloud storage and also database. And the last one is cloud storage monitoring for alerting service.
Indoor scenes. Bathroom. There is one object detected. Toilet is on the front. Indoor scenes. Museum. There. Indoor scenes. Bathroom. There is one object detected. Toilet is on the front side. Indoor scenes. Museum. There is one object detected. Person is on the left. Indoor scenes. Pool inside. No objects detected.
For things we should have done differently, there are some of them. For machine learning part, we should adding more dataset to add more features to class prediction, doing more tuning and on the model and parameter for better prediction result. For mobile development, we need to design a better front end and back end, and may make new layout for better interaction with user. For cloud computing part, serving ML model directly from cloud for a better performance, both infrastructure with professional level so it can handle heavy work.
That's all from us. Thank you so much for your attention, and see you on Deepsee development phase. Thank you all.